That'll set up our Q&A session, which will be at the end. Now, James, I'll go ahead and hand it over to you.
Awesome. Thanks so much. So welcome, everyone. My name is James Serra. I'm a data platform architecture lead at EY. Prior to this engagement or this move over to EY, which I've been here 6 months, I was at Microsoft for 7 years. Focus a lot on technology and pre-sales capacity on there, educating a lot of customers about their needs, data platform or AI related. So I spent a lot of time whiteboarding with customers, building out data architectures, and helping them understand all of the latest buzzwords. It was very popular recently, and we'll cover some of that today. I have a long career. I won't go back to my COBOL days, but I over the years done a lot with databases, data warehouses, and such. I blog a lot. So if a lot of what we talk about here has been on a deeper dive in my blog on some of these topics. You know, the topic of this, I'll go back, is building a multi-cloud data fabric for analytics. And I like to think of it, and we'll talk more about what a data fabric is, but in short, it is a glorified data warehouse. And this is what we're building at EY. This is what I'm in a workshop today in New York talking about, is a data fabric. When we get into a multi-cloud situation of there, is, do we need to build something out that is supported for more than one cloud? So that's one of the questions you ask. I'll ask a customer if I'm trying to understand what they're trying to build, and a lot of other questions I'll ask them. What is your current skill set? What size of data are we talking about? Do you need to stream the data? What's your budget and timeline? All these things come into play, because I'd love to say we have one architecture that everybody could use, but there isn't no standard architecture. There are standard topics, and you can think that there are standard concepts like a data lake, but what goes into building a solution technology-wise varies greatly depending on a lot of these questions that you need to ask yourself when you're building out a data fabric in there. So, and this deck will be available as a takeaway, but you have to really think through these things on there, because you want to make sure you are not making a poor decision early on. And I've seen customers who chose the wrong technologies, chose the wrong concepts, and are 6 months, a year into building a solution, sometimes a couple years into building a solution, and they realize it's not working for what they need, and they're out millions of dollars in a couple of years' time. The big thing that comes out of in talks with customers is, what is a data lake and why do I need one? And so I just wanted to review here there, because there's a lot of reasons that you want to use a data lake. And I'll just go through some of these here, but this slide started out with a handful, and over the past couple of years, I keep thinking of more and more things to add to about why you'd want to have a data lake on there. The first one is, it's a schema on read, meaning I can take data and I can put it into a data lake with little effort on there. You can think of a data lake as a glorified file folder, just like I can copy data into folders on my laptop with nothing that needs to be done up front, as opposed to schema on write, where if I'm creating a database, in a relational database, I have to create the database, the tables, the schema, write the ETL, and land it in there. So it's a lot of effort. And when I was a DBA for a dozen years, and there was nothing more annoying than somebody saying they needed this data real bad, an end user, and back in those days, it was just relational databases. So I'd go do all that work to put the data in there, and then they go, oh, it turns out I don't need that data, or it doesn't help me on there. And I wasted all this time. Now you can put data in a data lake and you can quickly analyze it, especially with the tools that we have nowadays, to see if that data has value. And then maybe you put it in a relational database on there, but the data lake gives you that immediate query into the data right away in there. It also frees up resources from your relational database. So for those who remember back before the data lake days, and this was only 10 years ago, when you had the relational database and you copied data in there, usually each night. So you had this maintenance window, and that maintenance window could be all night long, 8 hours. You're loading all this data and cleaning it using the compute of that data warehouse, and then opening up the maintenance window. And if something went wrong and it bled into the work hours in there, then you got a lot of mad users. What the data lake can do at the very least, think of it as taking that staging area that you had in the relational database and putting it in a data lake instead, and having the data in the data lake be cleaned separately. And you can also put as much compute as you want. You're not limited to what the relational database compute is. And I can have, say, a bunch of clusters of Databricks, for example, running, and I could spend money if I'm okay with the trade-off of getting the data clean quicker. And I can do all that and then move that clean data into the data warehouse, that relational side of it, which may only take a few seconds instead of having this maintenance window of a few hours, which has become a big thing as more and more databases I'm seeing are trying to be 24/7. They don't have time for a maintenance window in there. And the last, I'll just point out, if you have a end user who's a power user, as well as with some of the tools today, you can quickly and easily query that data in the data lake. So I'm starting to see cases where you may not need a relational database, which I never thought I would say a few years ago, but now with products in Microsoft's world, they have Synapse, you can use regular T-SQL over that data sitting in the data lake. And so you may be able to get the performance you need, generate the queries and the reports without having moved to a relational. So there's trade-offs, one being performance. You'll never get millisecond performance going from a data lake, but maybe that's okay. Maybe a few seconds for a dashboard or report is fine. It also could be that the security is not as robust on a data lake. For example, role of security is not there. And there's others, and just the complexity of having all this data in the data lake means that you, in most cases, still want a relational database. But I think we're starting to see this corner being turned where you can use a data lake and not have to have a relational database, which was the goal of Hadoop and data lakes 10 years ago, and that blew up. And it's taken 10 years for us finally get to the point where maybe you can get away with just a data lake. So when we compare the two, is okay, if I have both, how can I think about them at a high level? Think of the data lake as that staging area that I just explained and preparing all that data. So cleaning it and transforming it and joining it and doing all these things to then move it to the data warehouse. And the data warehouse becomes your serving and security layer, as I said, because it has additional security on top of it. And some customers will say nobody gets access to the data lake except very few people, maybe some data scientists. Everything else goes through a data warehouse on there because people are used to data warehouse. It has that extra security, and you can put the data in a format that's very easy to consume, like a star schema, compared to more of a challenge in the data lake in there. So this goes into the differences between the two. And I would say still about 95% of customers are having both. And if the exceptions will be, okay, maybe the data lake, I'm willing to have those trade-offs, as I explained before, and not have to have a data warehouse. Or I've been doing this a long time, I have a data warehouse, and we haven't used the data lake yet, in which case I'll start to see companies integrate a data lake by putting new data into the data lake because the data warehouse can't consume this data. Maybe it's IoT data, and I need to put it in the data lake. And so I'll have the combination of the two that way. And so the data lake is kind of behind the times because of just the way the system was built out. But if you're building something new, you in most cases are going to want to have both the data lake and the data warehouse.
And James, if I could chime in, just a question from my end, are you seeing more use cases with fast data SLAs on data warehouse and data lakes? Just as an example, use cases where the business groups need to ensure the data they're analyzing in that warehouse is actually up to date within 5 minutes or 10 minutes of what's going on in the operational database?
Yeah, that's a difficult question because of the scenarios being presented to end users now with data coming in. So if we look at really fast streaming data, IoT data coming off of sensors or Twitter data on there, generally that data will get to the data warehouse, but first, it will go through some other process to land in there. Usually it's in the data lake, and then there may be a tool right off of that. It could be that I have queries running as a data lake for that large amount of data, or it's going to something like Power BI, which you can use a streaming data set if I need immediate feedback, like I need to be aware when a sentry gets above a certain level, or there's a keyword in a log file that says error. And there's other products you can use like Data Explorer that Microsoft has for billions of rows in there. And so they're generally LC is there's for that type of real time, it's done in the data lake, aggregated at some point, and then parts of all that streaming data are put into a data warehouse for more of a historical trends and patterns that were looked at on there. I can't recall anybody trying to get to the point of a data warehouse that's going to suck in IoT data right into it. The data, it just relational databases really can't handle events that are coming at thousands per second or millions per second on there. And so I still see data warehouse more of a historical view. Now, the gray area is when, and I'll call it operational data store, which may be relational, where I need to get, say, a customer 360 view, and I have all these OLTP systems that have this customer data. What they'll do is they'll take that data from those systems in real time, move it into one location, and I'll call it an ODS instead of a data warehouse. And that can give them that real time need. Maybe somebody's calling up a customer service and they need to see all the customer's information. And so they pull from 3 or 4 sources, put it into ODS. That ODS will then feed into a data warehouse with a more of a historical point. Now, people have talked about Lambda architectures and trying to eventually get everything into a data warehouse. I just don't think the technology is there yet for us to have a data warehouse that's all relational, do all of that. So you have both the combination of a data lake and a data warehouse, and maybe you can get away with doing all that in a data lake and not a data warehouse. But in most cases, again, you'll have both. So hopefully that was a long answer to your one question.
Yeah, no, it's excellent. Thank you for getting deep into that topic.
Yeah. So I'll pause along the way for any other questions that you may have. I always like to level set with when I talk to customers too, of where are they on this data maturity stages on here. I'll find most customers are in stage 2, where they're trying to take all this data that's spread out everywhere and collect it in one location, one single source of the truth, one area where they can secure all the data and clean it and master it. That is usually in the cloud. It's very, very rare now I see anybody do things on-prem. And so that could be really helpful with the rear view mirror look in there. The idea is I can see those historical trends and patterns and get insights to the data, but I want to go a step further. And that's where we get to stage 3 and 4, where it's getting predictive and transformative is, can I start taking all that data and put machine learning models on top of that? So I can do predictive analytics. So instead of just looking at the history of when parts are broken, I can now predict when they're going to break, so I can fix them before they actually break. And so there's a million use cases you can see for that. And the idea is trying to get to that digital transformation and get to stage 4, the ultimate goal where I can use data no matter what the size, the speed, or the type is. And I have to build a system that can handle all that. The technology is there to do all that. The challenge is it could take some time and effort, and a lot of data governance has to be put in place to get to that point. But ideally, you get there and you have a system that's going to last many years, and you're not going to go, oh, wait a minute, I can't handle data that's being streamed in, or I can't handle data that's a certain petabyte of size on there. And so when I was at Microsoft and talked to customers, the idea is, let me ask all those questions up front in there, and then let's come up with an architecture that's going to last for quite a long time. The other big topic that I see with customers recently is trying to decide between a single cloud and a multi-cloud. And I recently blogged about this, and I'm of the opinion that single cloud is the way to go for many reasons. Now, there are certain benefits of a multi-cloud that I list here. I see some exceptions with customers who want to go the multi-cloud. It could be that, hey, I'm using, I won't name names, just a single cloud vendor, and they don't have this particular feature that I need. So I'm forced to go to another cloud vendor to get that feature. Okay, well, you either wait for that vendor to come up with that feature, or you decide to go and use that other cloud in there. It could be that capacity issues. I see this one a fair amount of time for those use cases of multi-cloud is I need a region in a certain country. Maybe it's because of some data sovereignty issues and the data can't leave there. And this particular product within a cloud does not have a region available in that country that I needed them. So if we look at any of the vendors, I'll use Microsoft because that's where I spend a lot of time, is they have, I think, something like 40 to 50 regions now across the world, but not every product that they have is in all those regions, especially when they're new. And maybe you need that product to be in a certain region, they don't have it, so I have to go with another vendor in there. It could be when we look at the reduced cost on there, and this is a very controversial one because the idea was that I can kind of play one vendor off the other in here. Hey, I'll just go to this other cloud vendor if you don't give me what I want. But that usually doesn't work because the cloud vendors will give you incentives to stay with them. If you pre-commit to a large amount of cloud usage in there, we'll give you a big discount. Well, you're not going to get a big discount if you're going to split with another vendor in there. So you can argue the other side of about the reduced cost thing in there, and that generally doesn't fly with them. And then the last thing I'll say is that the first one I listed on SLAs is I may need, as an example, access to a query that needs to come in within 10 milliseconds, but the group of users who are querying are forced to go to a region that's not really close, or maybe the technology is just not really that good enough for what they need, and they need to go to another cloud vendor to get technology that's faster and or has a region that's closer to the end users to meet those SLAs. So benefits of multi-cloud. The concerns, if you decide to go multi-cloud, is the performance on there is now I have to try to move data between one cloud and the other, and it's maybe affect performance on there. It's really hard just to say I'm going to completely separate all my data out. Usually there's going to be some cases where you have to move them over, and that's going to be a delay, and so your performance is going to suffer. I'll have to have multiple skill sets. I spent half my time at Microsoft just learning technology and keeping up with it, and I could barely keep up with the data platform. And the AI was another one that I really couldn't keep up with everything. Well, what about all the other areas of infrastructure and DevOps, and the challenge of having now to get people to know two clouds or divide it up so half people know one, half the other people know one is just a tremendous challenge in there. I remember just trying to learn the Azure portal, how long it took me. I can't imagine now trying to go learn another portal and get used to it. So there's that. I'll touch a couple others, is just the complexity now of dealing with two clouds and trying to keep up with the spending that's going on. That I saw a lot of customers really struggle with that because it takes different skill sets to understand all these charges in there, and now to understand how they're working together, and your overall cost is something that is a big challenge in there. And then I'll put the last one as the least common denominator in there. Meaning if I'm trying to get code that's going to work on multiple clouds, I have to dummy it down. It's got to work on both. And so some may have an advanced feature that I can't use because the other cloud doesn't have it. So I have to reduce that code to be that least common denominator. It reminds me of the days of web browsers when they first came out, and you try to have your code run on all the different web browsers. You got to pick and reduce your code to be portable, and it meant you had to remove a lot of features that were available in each of those browsers.
Just to chime in again, James, I think based on our experience with Stream, multi-cloud is already a reality for many large companies where, different groups are running data on different clouds. But there's certainly, when you're one domain and you're trying to decide, for my use case, do I want to be single cloud and multi-cloud? There's a lot of technical areas that users have to think about that you're pointing out here, which are really good. Yeah, thank you.
Yeah, John, this is a good point. Sometimes you're forced to multi-cloud. I mean, you can imagine I work at EY and they buy other companies and other companies are other clouds on there. And that's what I see a lot is, well, yeah, we'd like to be under vendor A, but the reality is we bought these other companies and they have a software that's running on a different cloud. So we're kind of forced that way. But if you're starting out or you're just on one vendor and you're thinking about it, okay, that's fine. But make sure you're aware of all these concerns so you don't decide to go multi-cloud and then later regret it. I want to touch a little bit of popping in a data warehouse. So the idea is, okay, we're going to build a data warehouse or a data fabric, and we need to collect data from multiple sources in there. Well, those sources of data could be small data sets, in which case I can just do a flush and fill, and maybe I can do that every day or week on there. So you have to think through these things because the cloud also change up things in there because something that you may do every night may take too long to upload to a cloud. So maybe you have to do it more frequently, like hourly and stuff. And the idea, the thought that you have to be is, do I do a full extraction? Meaning I can just take that data and a flush and fill it. And that could be fine in use cases where the data is smaller, usually dimension tables. But if you get into things like a fact table, you're going to need incremental extraction. I only want to pull in the things that have changed since the last time I did the extraction in there. Because a flush and fill of data that could be terabytes, if not petabytes of data is just not practical. So, okay, well, I'm going to need to know the data that's changed since the last time I did that extraction in there. And this is where there's a lot of options. Ideally, it'd be great if every record in this table had a last updated date, so I can quickly determine it. And if not, maybe I'm using something like SQL Server and I can use CDC on it, or some of the other things I put in here as ways to get around not having a timestamp on there. But sometimes these are limited because it may be a source system that you're not allowed to touch because it's a third-party product and they won't let you modify their databases on there. In which case, then you need to get into some third-party product, which is like Shrim and others that have ways of adding the ability to detect what's changed since the last time the extraction is. And this is where I see a lot of value out of these third-party companies, products, is because they've created ways that can allow you to do incremental updating because again, the full extraction could be too much. And so many times I see companies forced to go with a third-party product in order to get that date change. And then the last thing is online extraction, meaning I have to be careful when I'm pulling this data from some source that I don't affect the source system. And this is what the third-party products are really good at, is avoiding that problem. Because I've seen customers where they go into the source system and they're running these queries to pull the latest data, and they're affecting the people who are trying to read and store and update data in there. So this is where you get into, well, maybe a way around that is I replicate the data on, and so that source system gets replicated or gets a database snapshot or uses something like availability group. So there's a second copy, and that second copy will be used to extract the latest changes in there and not mess with that source system.
Yeah, and James, those are great points, and especially when it comes to incremental extraction, there's a lot of challenges that some third-party products will, hide from the user. But determining what's changed, capturing with low impact of the source system, especially if it's a operational database, but also things like log files, and also when we look at that, considering the costs of loading that to the data warehouse and making sure that's done efficiently, right? Because if your data warehouse is running 24/7 every single minute, uploading, incremental changes, that can have significant costs. And then some data warehouses, the way they even merge data, some of them require, full table scans, which again can drive up compute costs if the data warehouse charges by byte scan. So there are ways to make that more efficient through some third-party products do this. We've developed some IP for that at Stream, but really thinking about that end to end, right? You have the business use case of capturing incremental changes, but then also the technical infrastructure considerations around performance and cost?
I just say, like, talk to an expert who's done this a million times. And that's the other thing about third-party products, is that you're not going to have any use case that they haven't seen probably a million times before. So they're going to say, look, this is the best way to handle it, as opposed to going off on your own and going, well, let me turn CDC on or something. And all of a sudden, the database is getting overwhelmed with performance issues because something you turned on has overhead to it. And now you have all these end users screaming yelling at you. I've been in that situation before when I was at DBA, and these products didn't exist back in those days. So I'm so glad things have progressed. And also the challenge is that you could have some very old systems that the third-party company will know how to handle those. And because they could be very unique. At the other spectrum is you could be like, we're using SAP, and the third-party company will say, yeah, we've done this a gazillion times in here. Let's show you how our product works, and we're going to save you, in the long run, we're going to save you a ton of money because you're not going to develop something your own, and you're lowering the risks of you coming up with a solution that doesn't work right or does cause performance issues. Usually, if I have a lot of time with customers, I go and whiteboard this out, but at the same time, I've done it here already. So I always look at, we have 5 steps in a modern data warehouse. We ingest, store, transform, model, and visualize the data on here. And in this case, in green, I put the products, if you're using Azure, that satisfy each of these stages on here. But the idea is we got to put it into a data lake. We'll use some ETL tool like Azure Data Factory. We land it into the data lake. It comes in its raw format, and in which case we then use a product to clean that data. I've listed out in Azure Data Factory, you can use data flows or Databricks, or now Synapse serverless could be used to put it into that cleaned. And then you may join it and create a presentation layer. You could have a sandbox layer in there with a copy of the data. So a lot of things you can do with the data, and people can get access to it right away. And that's where I have my little person with a hat, a data scientist, who can make use of that data if you have the skill set to handle data that's sitting in the data lake. But in most cases, you're gonna move that data in step 4 and model it and put it into a relational database. And it could land in third normal form, which you can then convert it to a star schema for performance reasons and for self-service BI, because you're doing all the joining in this star schema. So making it easy for the end user to click and drag fields onto a dashboard and get value out of that and create those dashboards and reports on that. So that's what, at a very high level, modern data warehouse. And most people have these same steps. They may call them something different, but the flow of data is pretty much the same. Now, when we look at a data fabric, as I said before, I just see it as you're taking a traditional modern data warehouse, but that's conflicting. A traditional data warehouse, when it's moved to the cloud, we call it a modern data warehouse. At least that's my interpretation of it. And going one step further is we can call it a data fabric if we add certain other features to that data warehouse. Things like mastering the data, having extensive data access and policies on that data. You can imagine at EY with sensitive data, we have to make it very secure. So there's a very robust amount of code that we put in there to track that data. So not just using RBAC, but ABAC, attribute-based access control in there. The big thing recently in the last couple of years has been metadata catalog, because we have so much data. How do we know what we have? We need to have a metadata catalog. We also want to track the lineage of that data over time to see where it came from and how it got transformed. And then even get into things like API calls in order to access the data. And then setting up my data fabric to be building blocks. So those pieces of code can be used outside of the data fabric, which is something that I'm seeing a lot of customers do now. Is they may say, somebody within a company may say, hey, I like what you built data fabric, but for whatever reasons, we can't use the data fabric, but I like the code. Maybe you created this great data ingestion piece that I'd like to use. And so you modularize things in a way that can be used outside of what you built on there. And so this is kind of the way I think of data fabric is adding the additional features over your modern data warehouse. And then we get to the data lakehouse in there, which is starting to become a little more popular the last year or two. And this is in particular because Databricks is coming out with the idea that we don't need a relational database. We can make the database, the data warehouse, have the data lake work like a data warehouse. And this is where we've taken the idea of combining the data lake and the data warehouse into that term data lakehouse in there. And the way that Databricks says you can add the features of a relational database over a data lake is through the Delta Lake, which has been open sourced. So it's not just Databricks solutions that support data lake, things like Azure Synapse does too. And it adds these features over the data lake, like ACID compliance on there, data versioning, performance improvements. So you put all these relational database-like features into a Delta Lake, so you can, as I mentioned before, have a situation now where I can use just a data lake and not have to use a relational database on there. So that's one approach. I see that in more use cases recently because of the challenges with this approach is having to use a technology that is a little different. So if I'm using, say, T-SQL, and I can query a relational database, and now you say, well, you can query the data sitting in a data lake, but you have to use a different version of SQL, a Hive SQL or Spark SQL. The amount of pushback that you get is incredible, surprised me on there. So Microsoft said, well, let's allow you to use regular T-SQL against data sitting in a data lake. And that's where what Synapse does, and that's where I'm starting to see customers come around to, okay, this is great. I can use T-SQL over that data in a data lake. I can even move that data to a relational database and then not have to change the SQL because it'll be all the same in there. So this is an interesting technology, made it interesting going forward about this gray area of bypassing our relational database. So the use cases that I'm seeing is that there's 4 problems when it comes to having a relational database in the data lake. One is keeping the two in sync. So you have the reliability issue. The data warehouse being older, because if I'm keeping it in sync, it means there's going to be time before the data gets there. It could be a few seconds, a few minutes, it could be hours. There's a lot of machine learning that doesn't work well off of a relational database, but does work well off of a data lake. And of course, the cost. Now I'm having 2 copies of the data. I'm having 2 compute systems, so it could be much more costly to have data in a relational database and a data lake. So I want to point those out. But okay, if I skip the relational database, I've kind of talked about this. It's not going to be as fast, especially if your relational database is like Synapse has a multiple parallel processing technology in there. Less security, again, low level security, common level security, that kind of thing. Its complexity is if I just have all these file folders and I'm dumping data in there and I have many source systems, it can get very overwhelming for end users to go and try to make sense of all this data because it's just files and folders and there's no metadata that is kind of protecting the data like you get in a relational database. You have to do the work up front, but the benefit is now the metadata and the data coexist in a nice, easy to understand format, which you don't get with a data lake. And then there's just some missing features that even though we have Delta Lake are not in a data lake house in there, things like referential integrity and some workload management and stuff. But those are going away slowly as Delta Lake is improving on there, but it's still not 100%. And then the other thing that's really being talked about now is data mesh. And the big change in that is everything I mentioned before is centralizing the data, copying it all into one location. A data mesh takes a different approach where you decentralize the data. And it's kept, all the data is not copied, it's kept in separate domains. And instead of taking, say, HR and finance and some operational data and copying to one location, I have those domains, those organizations within my company keep the data within their org, and so it's decentralized. And they maintain ownership of that data as opposed to the data being centralized and IT owning the data. So it's a very different organizational change and understand the data mesh is more about organizational change than about technology. And this is the biggest thing to overcome with the data mesh, is that it's very hard for companies to break the way they view things, especially if they're a large company they've been doing a while. And there's many other concerns that I'll get into, but that is the one big difference is decentralized ownership. And the other thing is the pipelines are reduced because you don't have to copy all that data into a central location now. So the pipelines are, at least in theory, much quicker and less of that in a data mesh in there. And you also think of a data mesh as data as a product. And this is the change in the mindset in there. So what usually happens is each domain is given a contract and say, to make your data more valuable, you need to present it in a certain way, you need to clean it in a certain way, and treat it as a product that everybody can get access to very easily. As we show in this diagram here, think of what is centralized is data infrastructure as a platform. So when you're telling each of those domains to have a contract, the contract is going to be, look, you're going to clean the data, and here is some code to clean the data. You're going to make the data secure, and here's the code to make the data secure on there. So you're helping them along the way, but they need more technical skill sets on there. So you're decentralizing IT also. Instead of all the technical skill set being in IT, now it's being spread out among all of these domains. And the idea is that you can scale better that way because each of those domains now have their own people and the technology, and you can add more and more domains. You just add more people and you scale out instead of IT and being the bottleneck, and everything's going to go into IT, and IT is going to push back and say, look, we only have a certain amount of people and a certain amount of resources and compute in order to collect all this data, and you're overcoming that issue with the data mesh. So the use cases is the four listed here is getting away from the argument of who actually owns the data, which is, I've seen shouting matches in certain companies. No longer is the idea is the domain owns the data, and there's no question about it on there. And you also get away from, sometimes I've seen where nobody wants to have ownership of that. They all say it's somebody else's ownership in there. So that problem goes away. The lack of quality, which could be that, hey, if you're asking IT to clean the data, they may not understand it well or well enough. So if we have data mesh where the ownership is the domain, they know the data best, they know how to clean it best. So you improve the quality of the data that way. Organizational scaling, as I said before, that no longer is IT the bottleneck because you've created these domains with each of their own technical skill sets. And it overcomes, at least in theory, the problem with the central IT not being able to scale enough because the technology is not there yet. This gets into the concerns with the data mesh. And I only listed some of them here. There's a lot of others on my blog. There's even others I didn't put in there because I do have many concerns with the data mesh. And having been in the industry 35 years, I've seen the way organizations operate and the challenges they are going to have with implementing a data mesh. And I'll just touch on a couple of them, but one of them is there's no standard definition of a data mesh. So how can we expect people to go and build a data mesh if nobody can agree what it is? And this is the biggest challenge, I think, with the data mesh. And I don't know if that's going to change, because what I'm starting to see is companies come out with exceptions to the data mesh. And hey, we built a data mesh, except we didn't follow this and this and this. And so that now it's adding a lot of confusion. There's the performance is a big issue in there, because the first thing I thought about when I read about a data mesh was, okay, you have all these domains and they're keeping copies of their own data, but somebody's going to come along and say, I need to query this data and join it all together. Well, how are you going to do that? And yeah, there's virtualization software, but now you're adding complexity and extra cost, and that's not going to solve all the problems with performance in there. It'll solve some of them, but you're going to have a lot of issues with trying to combine all that data. And so the technology is just not there yet. And that's why I say data mesh is the theory of it all, but we need the technology behind it to make it effective, and we just don't have that yet. And the other thing that I see as a big challenge with data mesh is if you have each of those domains and you give them a contract to say you need to change the way you do things to make it appealing or easier for people to access your data, the domains are going to go, well, why should I do that? What's my incentive? You're going to ask me to have extra work now to do things differently. Why? And maybe you can say the greater good and they're going to go by that. But in most cases, this is where I see the domains are going to be like, look, if you want to take the data and mash it with others, fine, go ahead, take a copy of it. But I don't have time or the desire to change the way I do things just to be part of this data mesh. And all it takes is one domain saying that, and now you could have everybody but one in a data mesh, and now you have struggle with, well, I do need that data. What am I going to do? And so that's probably number one problem I've seen with customers thinking about the data mesh is just that. But if you do go ahead with the data mesh, I've listed some things that you have to, some keys to be successful in there. So the biggest one is just don't go to data mesh unless you have all these major pain points already, where you're having trouble scaling, where you're having trouble with ownership, where you're having trouble of combining the data and getting value out of that. So don't just go because, oh, it sounds cool. Have real big issues in there, because the data mesh is going to take a long time to implement, especially if you have a lot of domains. It could take a couple of years at the least on there. So be aware of that. And the others is just have the experienced people on there. Don't go strictly by what the book says in the data mesh there. It's okay to have exceptions to it. And so understand the theory, but understand the technology is not there yet and where you can make those exceptions. And the big one I see is centralizing the data. So instead of having all the domains have their own data lake, you have one data lake that is split out by folders for each of those domains. So the data is all close and centralized, and it makes it a lot easier to query all the data and not have to use virtualization software as opposed to the way it's done in theory. And take away in the slide, there are a handful of companies that have created videos on how they've done data mesh, so you can watch them and see. But understand these are all very big companies with very big problems in there. And if you're not in that use case, then the data mesh is probably not for you. And the Microsoft has an exceptions on here. So this is where I mentioned before at the bottom, they actually centralize the data, and that's their approach. They call it this harmonized mesh on there, and they have some documentation on this now, but I'm told that they're gonna come out and expand a lot more on this and promote a lot more as how can you create a data mesh using Microsoft's products. Go ahead.
I know we're running on time, but just to go back to that slide with the centralized, yeah, and that's critical. I can provide some technical context, architectural context that, let's say there's 5 different domains that want to access the same operational data from a database. They can't all be querying the operational database for analytical purposes or, domain-oriented purposes, or that would slow the operational database down to a halt. So that's why it's critical to have that one centralized ingest pipeline, data infrastructure as a pipeline, and then let the domain groups build on top of that. Does that sound correct, James?
Yeah. And this is where another concern I have with the data mesh is that they don't explain well enough. If I have all these source systems and they're all OLTP systems, and I'm creating a domain of analytical data, how do I do that? And there's very little documentation on that. And you need to your point, you need to understand is you don't want to query the data in the OLTP. You want to copy it into a different format inside a domain and then allow end users to access that data. And that could be through products like Strim that take the data from the source system and copy it over into another location, so you're not have everybody hammering the OLTP system. And that's where I wish they would do more of explanation of how do they see each of the domains, taking the OLTP data and making data analytics copies out of it. Yeah, and last I'll just touch on, a lot of people say, what's the difference between a data fabric and a data mesh? So I have these in the slides as takeaway. And I think I talked about most of this, but this makes it easy to understand. And then the last is the multi-cloud data fabric is the idea of I can build a data fabric that can run on more than one cloud. And if I want to do that, I kind of listed out some of the things you have to think about on this slide. And so I don't know if John, you want to comment on these, but this is what I think you need to think through if you're going to have this multi-cloud approach.
Yeah, absolutely, James. I think this summarizes it really well. I think we're right at time to get into Q&A.
Yeah,
you so
awesome.
much, James.
So I'll take the next 10 minutes or so to answer any questions that come along, but feel free to reach out to me after this and send me an email. I spend part of my day, almost every day, helping to answer questions from others. So I'm happy to do that.
Thanks so much, James.
Yeah, so Jason says his data's in Mongo. He's streaming it into a few other different sources. What way to test all the data? Oh yeah, this is good. So I remember having this challenge many years ago where, okay, I take data from the source system and then I copy it into this staging area and it's in a data lake, and then I copy that data and I clean it, and then I master it, and then I join it, and then it goes from the data lake to a relational database, and then it goes from there to, say, a Power BI report. How do I verify all this data is correct on there? Well, actually, row counts are probably the best way to go. I would, and I tell customers this: just have queries that's going to run after this data is all transformed. And you say, I know the count should be the same, or if I'm aggregations, then I should do a sum of the data. So maybe taking the data from today and taking one of the fields with a value in there, like a dollar figure, and then saying this should equal from the source system to the staging in the data lake, into the presentation layer in the data lake, into the relational database, into the Power BI report. I haven't really found any tool that was good at helping you audit and verify all that, other than just creating your own queries to go against all of that. So I wish I had a great, cool, slick way of saying do it, but differently than that, but that's really what it comes down to.
Thanks, James. And I can add to that one that, I've helped customers automate this before. That's a great question. And especially when you're looking at streaming ETL versus like a batch load, like if you're thinking in the batch world, okay, I'm going to copy all the rows from this table in Mongo to Postgres, then, count star. But yet, like you said, James, totally works. You're talking about streaming ETL. You have to take into consideration when you started streaming those changes, and are they the rows themselves, or are you streaming changes? When I say change, I mean like DML statements like updates, deletes. So if you're streaming the changes, there might not be an exact match between what you have in your source and your target, and that's okay. That's expected. So yeah, just wanted to chime in on that point as well.
Yeah, and what I've started seeing some customers do is they introduce machine learning algorithms to say if the count seems out of the ordinary, if it's an outlier. And so I've seen some pretty sophisticated ways of trying to trigger at least a email alert that somebody should go look at this because it doesn't seem right. And you can do that with some pre-built machine learning algorithm models that are out there as a way to kind of level check what the totals are, what each day's ETL is doing.
Excellent.
All right, cool. Amir asks, what do you think about the Lakehouse versus data warehouse? Do you think one data warehouse is still needed with these great OLAP on data warehouses creating data marts? Do we see them to centralize everything? And is there a way to keep everything in a data warehouse that's not driven by OLAP data marts? So yeah, so this is kind of what I touched on before. And when I draw out an architecture from customers, and I say, look, the data is going to go from a source system into a data lake. It's going to have multiple layers. It's going to go. It's going to go to a relational database. And I always point out we're creating multiple copies of the data, so more ETL, more expense. But the benefits we gain is the data as it moves along is becoming in a format that's much more easier for end users to consume. So if I go all the way into a star schema, you can get that self-service BI where it's very easy for end users to create their own dashboards and reports. And so it is worth the extra cost and effort to copy that data. Maybe if you have more sophisticated end users or the technology's got to a point, like it is getting with Synapse, where I can use regular T-SQL over the data in the data lake. Because what you can do with Synapse is you can create a view that has schema information in it on the file that's sitting in a data lake. And so to the end user, they think the data is actually sitting in a relational database because it appears that way when it's not. And so you're putting this layer on top of it that makes it easier to query. But again, you're putting extra work on it. Somebody's now got to create that view, but it's not as difficult or time consuming as putting it into a relational database. So that's where I see some of this changing, and could agree in certain use cases to just use the data lake in there. And then some of it also depends on the relational database, the source systems. Now, if you look at something like a Cosmos DB, it automatically copies the data over into an analytical format, so you can query right off of that. So you're not messing with the OLTP, or you use like a product like Stream that's automatically doing it. So in the end, I have to look and do discovery with the customer and ask all those questions I showed up front of what they're doing and what they want to do. And that's going to guide me into the solution. And the only way you can do it is spend a lot of time up front asking those questions and then seeing what's going to work, because it's just so much depends on the type of data and the size and the speed.
Great
Right. Yeah. Have you looked at Snowflake? Yes. Of course, at Microsoft, they were a big competitor to Synapse Analytics. And at EY, it's something that they use both of. They have Snowflake in certain environments here, as well as Synapse. So it's a very good product. It's got its certain benefits over Synapse, and then Synapse has got a certain benefits over Snowflake. I would say the one big difference between the two is Snowflake is focused on the relational database part of that, and Synapse has that, but also a data lake. It also has ETL data factory in there. It also has Power BI. So it's more of a ecosystem. Whether that's, you can say that's good or bad. It's a little bit hard to compare apples to apples on that. But you can go into the details of Synapse and the dedicated pool, the relational part of that compared to the Snowflake. And I've seen many bake-offs, and I was part of a lot of client meetings where they were debating between the two of them. And the technologies, both sides are getting better and better. But Snowflake is a popular product, and you definitely want to check that out as one of the many options. So when I come up with this architecture with customers, one of the questions I ask is, what are you already using? And if they're using, say, Informatica, I'm going to say, okay, continue using that for your ETL. If they don't say, this is brand new, we don't know what to use, well, do you want to stay and use everything Microsoft? Then okay, then Data Factory may be your option there. But you have to see what's already in place. And then we get into costs and licensing. I wish we didn't have to worry about those things, but we do. So that drives a lot of customers' decisions on what products they wind up using in building out a data fabric. And so I think we have time for one more. So looking at, Mohammed says, using data mesh and different ADLS accounts, how do we combine all of the domains to build BI reports? So this is the challenge I said before, is you have all these domains having their own data lake. Microsoft says, well, we're not going to do that. We're going to centralize everything and just have one data lake with different folders. There are workarounds to that. You can have data lake, and you can have, well, it's too much to get into now, but there are ways you can have a query point to multiple data lakes in there. But the trade-off is then performance, because now those data lakes are storage accounts that could be anywhere in there. And what they've recently changed in the data mesh theory is to have other domains besides the source domain. Is now they have aggregate domains, and they also have these business domains, I think they call them, on there. And the idea is you're creating copies of that data for performance reasons and aggregating and putting it into another domain, which goes against what they originally said of the data fabric. And they kind of changed their tune in ways. Is that, well, now you're saying you're going to copy the data as opposed to what you originally said was everything in the domain. But I think they were forced to come up with that solution because of the performance issues of trying to combine all this data in these different domains. So, and that's where we see each vendor coming up with different ways of getting that performance by having additional copies of that data. And I don't think there's a great solution yet on there. Maybe we'll get to that point one day, but for now, you're gonna have to have these workarounds.
Well, we are right at the top of the hour. Thank you everyone for joining. We want to share the poll results here. If everyone noticed that majority of people are going to use at least as part of our sample, the attendees of this session, looks like leaning on hybrid of on-premise and clouds, multiple clouds, then one cloud. No one chose fully on-premise, definitely in the right place today, given the topics we covered. And thank you again, James. James, we have one last question. Do you have time to answer that?
Sure. Most people use data fabric and data mesh interchangeably. What is the one key distinction between the two? One is one superior than the other? And so I don't know if you can see myself, but that was one of the slides I had. So when they're using interchangeably, it's kind of interesting is that I've seen some customers say they're creating a data mesh, but there are certain pieces of it that are not traditional data mesh, that they're using a data fabric or a modern data warehouse in there. And so what I'm starting to see is the way you can say, well, let me build a modern data warehouse and combine all this data and centralize it, and then take that and combine it with some other domains that are agreeing to present their data using the contract I specified. And so I have this one exception over here where I've centralized the data for maybe a handful of domains, and then I'm using those other domains. And so I have a kind of a hybrid data mesh in there. And so I think that's going to be the way people solve the challenge of, if I need to combine this data frequently, let me just centralize it and make that centralization of domain. And that's kind of where they changed in the approach of the data mesh, was create these aggregated domains, because customers were just going and doing that because they had no choice on there. So now you have this hybrid approach, and I think that could work well. And it'll be interesting to see in the next couple of years when customers finally put the data mesh production for a while, what are their challenges that they overcame, and what are their continued challenges that they're having, and has the technology caught up yet to solve some of them?
Well, thank you very much, James, for joining today. That was a really great discussion. And thank you to everyone who attended. And we will follow up. And yes, everyone will get the slide deck, and you'll also get a video recording of today's session, so you can go back and refer to a lot of the rich topics that James covered today. Great. Yeah. Thanks, James.
Yeah, this is a lot of fun. I can talk about this stuff all day long. So again, if you have any questions that we didn't answer, feel free to email me, and I'm happy to reply.
Excellent. Thank you, everybody.